How John Deere compact tractors are made inside the tractor factory, full process. Intro. What does it take to build one of the world's most reliable compact tractors? Every single day, inside a massive high-tech manufacturing facility, giant robotic machines, skilled engineers, and advanced assembly systems work together to create the powerful green and yellow machines trusted by farmers, landscapers, construction crews, and property owners around the world. Today, we are going deep inside the fascinating world of tractor manufacturing to witness the complete production process of John Deere compact tractors. From raw steel and precision-engineered engines to hydraulic systems, heavy-duty frames, and final testing, every tractor goes through an extraordinary journey before it finally reaches farms and worksites across the globe. Compact tractors may look smaller than giant agricultural machines, but the engineering behind them is incredibly advanced. These machines are designed to work long hours in difficult environments while handling heavy loads, rough terrain, and demanding tasks every single day. Inside the factory, every second matters. Robotic arms weld steel with incredible precision. Automated systems transport massive components across assembly lines. Technicians carefully inspect thousands of individual parts. And slowly, another powerful compact tractor comes to life. So sit back, relax, and let's go inside the tractor factory to discover the complete process of how John Deere compact tractors are made. Section 1: Designing the compact tractor. Before production begins, years of engineering and development take place behind the scenes. Designing a modern compact tractor is far more complicated than many people realize. Engineers must create a machine that is powerful, fuel-efficient, durable, comfortable, easy to operate, and capable of performing multiple tasks in different environments. Compact tractors are used for farming, landscaping, construction, snow removal, hauling, mowing, and many other applications. That means every machine must be flexible enough to handle different attachments and working conditions. Using advanced computer modeling systems, engineers design every component digitally before physical production begins. They test structural strength, engine performance, hydraulic systems, cooling efficiency, stability, and operator safety using sophisticated simulations. Even the placement of controls, seats, pedals, and displays is carefully engineered for comfort and efficiency. Modern tractors also include advanced electronic systems and smart technology. Manufacturers constantly work to improve fuel economy, reduce emissions, and increase productivity. Once the final design is approved, the manufacturing process begins. Every day, huge shipments of steel, engines, tires, hydraulic components, axles, transmissions, and electronic systems arrive at the factory. The scale of production is enormous. Thousands of parts must arrive at exactly the right time to keep assembly moving smoothly. And the very first stage begins with raw steel. Section 2: Frame and Chassis Construction. The backbone of every compact tractor is its frame and chassis. This heavy-duty structure supports the engine, transmission, hydraulic systems, wheels, operator station, and attachments. The process begins in the steel fabrication area. Large steel beams and metal sheets are measured and cut using advanced automated machinery. Computer-controlled laser cutting systems shape metal components with incredible precision. Every measurement must be exact. Even the smallest error could affect alignment during final assembly. After cutting, the components move into the welding area. Here, robotic welding systems and skilled technicians work together to assemble the tractor frame. Bright sparks fly through the air as steel pieces are welded into strong structural sections. Robotic welding plays a huge role in modern tractor production because it ensures consistency and strength. Each robot performs thousands of welds every day with extreme precision. Laser-guided systems continuously monitor positioning during the welding process. But despite the advanced automation, human workers remain essential. Technicians inspect weld quality, supervise robotic operations, and handle complex assembly tasks requiring human expertise. Once the frame is completed, it undergoes detailed quality inspections. Laser measurement systems verify alignment and structural accuracy. The chassis must be perfectly balanced because compact tractors operate on uneven terrain while carrying heavy equipment. After inspection, the completed frame moves toward the next stage of production. Section 3: Machining Engine Components. Meanwhile, inside another section of the factory, Engineers are building the heart of the tractor. The engine. Compact tractor engines may be smaller than massive agricultural engines, but they are still engineering masterpieces designed for durability and efficiency. The engine production process begins with large metal castings. Engine blocks and cylinder heads are manufactured using high-strength alloys capable of surviving intense heat and pressure. Advanced CNC machining centers shape these components with microscopic precision. Massive computer-controlled machines drill holes, polish surfaces, and cut metal accurately down to tiny fractions of a millimeter. Precision is critical. Even a tiny imperfection inside the engine could affect performance, fuel economy, or long-term reliability. After machining, the engine assembly process begins. Workers and automated systems carefully install crankshafts, pistons, connecting rods, camshafts, injectors, turbochargers, cooling systems, and fuel components. Modern diesel engines are highly advanced. Electronic systems constantly monitor fuel injection timing, combustion efficiency, airflow, and emissions. Environmental regulations continue becoming stricter every year, so manufacturers invest heavily in cleaner engine technologies. Once assembly is complete, every engine undergoes extensive testing. Before installation into a tractor, engineers run the engine under simulated working conditions. Computers monitor oil pressure, vibration, temperature, fuel consumption, and power output. Only engines that pass every inspection move forward in production. Section 4: Transmission and Hydraulic Systems. One of the most important features of any tractor is its transmission and hydraulic system. These systems allow the tractor to pull heavy equipment, lift attachments, and perform demanding agricultural and industrial tasks. Inside the transmission assembly area, workers install gears, shafts, bearings, clutch systems, and drive components with incredible precision. Modern compact tractors often use hydrostatic or advanced automatic transmissions designed for smooth operation and easy control. These systems help operators work more efficiently while reducing fatigue. At the same time, hydraulic systems are assembled. Hydraulics are essential because they power loaders, mowers, backhoes, and many other tractor attachments. High-pressure pumps, hydraulic lines, control valves, and cylinders are carefully installed and tested. The hydraulic system must generate enormous force while operating reliably under extreme conditions. Even a small hydraulic leak could affect performance. That is why every connection undergoes careful inspection before final assembly. Once transmissions and hydraulic systems are completed, they are prepared for installation onto the tractor chassis. Section 5: Axles, Suspension, and Drivetrain Installation. As the tractor frame moves down the assembly line, workers begin installing heavy-duty axles and drivetrain components. Compact tractors are built to operate on rough terrain, muddy fields, rocky surfaces, and steep slopes. Because of this, the drivetrain must be incredibly durable. Front and rear axles are mounted carefully onto the chassis. Drive shafts, differential systems, and steering components are connected. Many compact tractors use four-wheel drive systems to improve traction and pulling power. Engineers carefully design these systems to maximize stability and performance in difficult working environments. Next comes tire installation. Large agricultural tires are mounted onto heavy-duty wheels using specialized equipment. Different tire types may be installed depending on the tractor's intended use. Some tractors use turf tires for landscaping. Others use aggressive agricultural tires for farming. Industrial tires are designed for construction and heavy-duty work. Once mounted, the tractor finally begins to look like a complete machine. Section 6: The Paint Shop. Before final assembly continues, tractor components enter the paint shop. This is one of the cleanest and most technologically advanced areas inside the factory. The famous green and yellow John Deere color scheme begins here. Before painting, every component is cleaned carefully to remove dust, oils, and contaminants. The parts then undergo anti-corrosion treatment to protect against rust and environmental damage. Tractors operate outdoors in rain, mud, snow, and extreme temperatures for years. Without proper protection, corrosion could seriously shorten the machine's lifespan. After cleaning and treatment, robotic painting systems apply multiple layers of primer and paint. Large robotic arms move smoothly around each component, spraying paint evenly with incredible precision. Computer systems control paint thickness and spray patterns automatically. This improves efficiency while reducing paint waste. After painting, the components enter giant curing ovens where heat hardens the finish into a durable protective coating. When the parts emerge from the ovens, they shine with the iconic John Deere appearance recognized around the world. Section 7 Final assembly begins. Now comes one of the most exciting stages of production. Final assembly. The painted chassis, engine, transmission, hydraulic systems, and drivetrain components finally come together. Large automated lifting systems carefully position the engine into the tractor frame. Everything must align perfectly. Workers connect fuel systems, cooling systems, electrical wiring, hydraulic lines, and drivetrain components. This process requires incredible coordination and precision. As assembly continues, the tractor slowly transforms into a complete working machine. The operator station is installed next. Seats, steering wheels, pedals, dashboards, and control systems are mounted carefully. Modern compact tractors include advanced digital displays and electronic controls that provide real-time performance information. Some tractors also include climate-controlled cabins with heating and air conditioning for operator comfort. Comfort is extremely important because operators may spend long hours working in the machine. Next, technicians install safety structures. Rollover protection systems are added to protect operators during accidents. Lighting systems, mirrors, warning signals, and protective guards are also installed. Modern safety standards for agricultural equipment are extremely strict. Every tractor must meet rigorous safety requirements before delivery. Section 8 Electrical Systems and Smart Technology. Modern compact tractors are far more advanced than many people realize. They contain sophisticated electrical systems and smart technology designed to improve efficiency and productivity. Technicians carefully install wiring harnesses throughout the tractor. These electrical systems connect sensors, displays, lights, ignition systems, engine controls, and hydraulic monitoring systems. Every connection must be perfect. A single faulty wire could create major problems later. Advanced diagnostic systems are used constantly during assembly to verify electrical performance. Modern tractors may include GPS guidance systems, digital monitoring displays, automated control systems, and remote diagnostic technology. Some advanced models can even connect to mobile apps and farm management software. Technology is transforming modern agriculture rapidly. Manufacturers continue integrating smarter systems into compact tractors every year. Section 9 Installing Attachment Systems. One major advantage of compact tractors is versatility. These machines can use many different attachments for different jobs. Because of this, attachment systems are extremely important during production. Technicians install front loader mounts, rear hitch systems, and power takeoff components. The power takeoff system, often called PTO, transfers engine power to external equipment such as mowers, tillers, and balers. Hydraulic attachment connections are also installed carefully. These systems allow operators to switch between attachments quickly and efficiently. Modern compact tractors are designed to become multi-purpose machines capable of handling dozens of different tasks. That flexibility makes them valuable for farms, construction sites, and landscaping operations. Section 10 Fluid Filling and First Engine Startup. As assembly nears completion, technicians begin adding fluids. Engine oil, coolant, hydraulic fluid, transmission fluid, diesel fuel. Now comes one of the most exciting moments in the factory. The first engine startup. For the very first time, the tractor comes alive. Technicians activate the electrical systems while engineers monitor diagnostic computers closely. Then the engine starts. The sound of the diesel engine echoes across the assembly hall. This moment is extremely important. Computers immediately begin checking oil pressure, fuel systems, cooling performance, emissions, and electronic functions. Any irregular reading triggers additional inspection. The tractor now moves under its own power for the first time. But before it can leave the factory, it must pass extensive testing. Section 11 Quality Control and Testing. Every John Deere compact tractor undergoes rigorous inspections before shipment. These machines must operate reliably under demanding conditions for many years. The first stage involves computerized inspections. Laser scanners analyze alignment, paint quality, and assembly precision. Even tiny imperfections are corrected immediately. Next comes hydraulic testing. Engineers verify hydraulic pressure, lifting capability, and attach.